Acids are everywhere. Many things contain acid. Some foods contain acid. These foods have a sour, sharp, tangy taste. Lemons and limes taste sour. They contain citric acid. This is a weak acid. Common acids in the laboratory are hydrochloric acid, sulfuric acid, and nitric acid. Some acids are dangerous. Some acids are strong. They are corrosive. The bottles have a hazard warning label. If strong acid gets onto your skin, it will dissolve the skin. You will get a chemical burn. Always use eye protection when using acids. Acids can be diluted with water. This makes them less dangerous. Dilute acids are still harmful. They can irritate your skin and eyes. The bottles have hazard warning labels. If you spill acid, wash the area with lots of water. The water dilutes the acid. Alkalis are everywhere. Many cleaning products contain alkalis such as sodium hydroxide, which is a compound of sodium, hydrogen, and oxygen. Sodium hydroxide is a strong alkali. Strong alkalis are dangerous. They are corrosive. If strong alkali gets on your skin, it dissolves your skin. Your skin feels soapy. You get a chemical burn. Alkalis are harmful if you get them in your eyes. Always wear eye protection when using alkalis. Alkalis can be diluted with water. This makes them less dangerous. Common alkalis found in the laboratory are sodium hydroxide, potassium hydroxide, and calcium hydroxide. Acids and alkalis are chemical opposites. They cancel each other out when they are mixed together. The acidity or alkalinity of a substance is a chemical property of that substance.
All right, quick safety sprint so you can handle acids and alkalis like a pro without the drama. Step 1. I stand up when I work. Always. If something tips, it hits the bench, not my lap. Mobility is safety. I can step back fast. Step 2. Safety glasses on before I even touch a bottle. Eyes don't heal from acid burns the way jeans do. Lenses beat regrets every time. Step 3. Bottle etiquette. I take the cap off and park it upside down on the bench. Why? No acid on the bench, no mystery dust in the bottle. Clean cap, clean chemistry. Step 4. When I'm done, I cap it immediately. Don't just for a second a chemical bottle. That's how spills happen, and how the wrong cap ends up on the wrong bottle. Now, the labels that talk to me before I pour. Explosive symbol. This stuff can blow if heated or sparked. Translation: no flames, no friction, store cool, open gently. Flammable, lights up easily. Keep away from burners, hot plates, and that it's barely on lighter. Oxidizing, feeds fires with extra oxygen-like power. It can turn a small flame into a big problem. Keep it away from fuels. Corrosive, eats living tissue and many materials. I wear glasses, I wear gloves, I wear lab coat, and I pour slow, aiming away from me. If it splashes, water rinse, lots of it. Toxic, can poison me by breathing, touching, or swallowing. Use minimal amounts, good ventilation, don't pipette by mouth, ever. Hazardous to the environment. Bad news for fish, plants, the whole food chain, never dump it. I use the proper waste container, every time. Health hazard, can irritate skin, eyes, lungs, or cause allergies. I avoid contact, close the bottle, and wash up after. Serious health hazard, long-term damage like cancer, or organ harm. Respect the data sheet, minimize exposure, keep it sealed. Pouring basics. Labels up, spout down. Labels up so drips don't smear the info, spout down for control. I pour at bench height, not chest height.
Flammable. Serious health hazard. Oxidizing. Hazardous to the environment. Health hazard. Toxic. Corrosive. Explosive.